Today's learning target is I can find theoretical probability and I can find experimental probability. Today we're going to talk about two different types of probability. One is called theoretical probability and the other is experimental probability. Now, in theoretical probability, that's what should happen when you conduct an experiment. Okay? So let's say we flip this coin here. The theoretical probability says it should land on heads 1 out of the 2 times. And it's 1 out of 2 because there's one head on that coin and there's 2 possible outcomes, heads or tails. However, if you've ever experimented with this and tried it, you know that if you flip a coin twice, it doesn't mean that it's going to land on heads once and tails once. So the experimental probability is what actually does happen when you conduct the experiment. So if you flip that coin and it lands on heads twice, then the probability is 2 out of 2 because there were 2 possible outcomes and heads was flipped twice. Or maybe tails was flipped both times. So the experimental probability of getting the heads was 0 out of 2 because again you flipped it twice and heads was 0 times. So think about experimental is experiment. Experiment is doing something. So that's the probability of what actually does happen when you conduct the experiment. And the theoretical probability is what should happen. It's the theory is the base word there. So let's find the experimental probability of a problem. So here it says 2 dice were rolled 75 times. Doubles, so like a 1 and a 1, a 2 and a 2, a 3 and a 3. So doubles were rolled 10 times. So in those 75 rolls, doubles were rolled 10 times. What is the experimental probability of rolling doubles? Now remember, experimental probability is what actually does happen. So in this case, the 2 dice were rolled 75 times and 10 times doubles were rolled. So to show this in probability, the experimental probability, we rolled the doubles 10 times out of a total of 75 times. So the experimental probability is 10 out of 75. Now you notice that we write probability just like we write fractions here. Okay, and just like in fractions, we want to simplify the probability. So I see that I can divide both of these by 5 to simplify it, and when I do that, I end up getting 2 out of 15. So the experimental probability would be 2 out of 15. So let's take a look at finding the theoretical and experimental probability when drawing a card out of a deck. In a normal deck of cards there are 4 suits. We've got hearts, spades, clubs, and diamonds, and there are 52 cards in a deck of cards. Each suit has 13 different cards of that suit in a deck, and that's a total of 52. So the theoretical probability of drawing a heart would be 13 out of 52 because there are 13 hearts in a deck of cards and there's a total of 52 cards in that deck. So it would be 13 out of 52. Now I can simplify 13 out of 52 by dividing both of these by 13 and I would get 1/4. So another way to look at that would be the probability, the theoretical probability or in theory would be 1 out of 4. And that's going to be the same for each one of these because there's 13 cards of each suit out of 52. So the theoretical probability of drawing any specific card would be 1 out of 4 or 13 out of 52. However, we know that if we experiment with this and try it out, it's not going to work out perfectly that way. I'm not going to get a heart 1 out of every 4 times that I draw and a spade 1 out of 4 times. And this graph shows that here. So we can see that a card was picked out of a deck 50 times. Okay, and I know it's 50 because here are, if I add up the number of clubs that were picked, the spades, the diamonds, and the hearts, this here equals 50. So the experimental probability of getting the heart, of picking a heart out of that deck was 17 out of 50. So 17 times it was picked out of a total of 50 times, or 17 times it was a heart. For diamonds, it was 8 out of 50 was the experimental probability. Now I notice both of those are even, so I could simplify that down to 4 out of 25 times. Spades was 13 out of 50 would be the experimental probability, and clubs was 12 out of 50, which if I see they're both even, so it'd be 6 out of 25 would be the experimental probability.